In section 3.3, we're going to solve for systems of inequalities. So the goal in this section is going to be to solve a system of linear equations as well as one that has an absolute value in it. So we worked with this a little bit last chapter, but just to recap, let's solve this system of equations. So we have 2x minus y is greater than or equal to negative 3, and y is greater than or equal to negative 1/2 x plus 1. So starting with this first equation, what I'm going to want to do is get the y by itself. So how I'm going to do that first is I'm going to bring over the 2x by subtracting it. And then the last thing that I want to do, and this step's important, since there's a negative 1 with the y, it's technically not by itself yet. So what I want to do, again, you could look at this as multiplying or dividing everything by negative 1. When I do that, negative times negative y is going to turn positive. Since I'm multiplying here by a negative, my sign is going to change to be less than or equal to, and then all of the signs on the other terms are going to change as well. So the negative is going to turn to positive 3 plus 2x. From here, now I'm in slope-intercept form, and it's a little bit easier for me to see where my starting point is and how to graph it. So here, I'm going to start at 0, 3, and the 2x tells you I'm going to go up 2 over 1, up 2 over 1. Since it's less than or equal to, I want to include the line. So I'm going to make my line here. And finally, I want less than, so everything below this line is a solution for that equation. The next line I'm going to do is y is greater than or equal to negative 1/2 x plus 1. Now this one's already in slope-intercept form, so I can see here that I start at 1, and I'm going down 1 over 2. This is greater than or equal to, so again here I want to include the line. And last but not least, I want to shade above this because it's greater than. So I'll shade here. And now after graphing both of these equations, I can see that my solution is going to be this area over here. So if you were asked to pick, for say, a solution in this system of equations, it would be any coordinate in that dark pink area. So for example, a solution could be the coordinate 3, 3. There's an infinite amount of solutions that I could have here. The next example that we're going to look at is an absolute value inequality. So the same thing, all that we're doing is just working in an absolute value function with this. So here we have y is less than or equal to 3, and y is greater than or equal to the absolute value of x minus 1. So to start, we have y is less than or equal to 3. Something to remember here, I'll write this down in your notes. If you just see y equals or y is greater than or equal to a number, that means it's a horizontal line. And if you have x is equal to a number like x with an inequality and it's just a number, that means that it's a vertical line. So for example, this line here, y is less than or equal to 3. I'm just going to go to 3 because that's its y-intercept. And this line would have a slope of 0. So that's why it's just a horizontal line. That line kind of sucked. And there we go. For this equation, less than is just going to be below the line here. So I want anything in there. Now, for my next line, y is greater than or equal to x minus 1, I want to remember from chapter 2 how to find my vertex and my a value. So in this equation, I can read that my vertex is at 1, 0, and my a value is 1. So what I'm going to do is move to the point 1, 0, and then since my a value is 1, I'm just going to go up 1 over 1. Since it's greater than or equal to, I'm going to make it a solid line. And since it's greater than, it would be anything in this area. So that means that my solution would be this area here. So any coordinate in that specific region would work. So an example of a solution here could be the coordinate 1, 2. That would work as a solution.